Okay, let's create the first part. Start by inserting a new part into the assembly. I'm going to label it FrontBack because it's going to be both the front and back after I mirror it a little later on. Now we have to anchor it in space. We start by mirroring the right plane with the assembly and the top plane with the assembly, but the front plane we're going to mirror to that plane that we created the sketch of the front sketch on. Yeah, now we're ready to go. I'm going to check the mates here, make sure I don't have anything crazy down there, and we'll open up the part. And the first step is always to import that equations file. If I'm doing a woodworking project, I want to have all the parts using the same equations file. Now I'll start creating the part by doing a sketch on the front plane, and I'm just going to select the perimeter of the front. Do an extruded boss base up to a vertex, and we're going to use the inside point from the inside of the box taken from the sketch. And we'll draw a sketch on that surface, and I'm going to hide it because I don't I guess I can draw the geometry there from now on, but it's in the way. I want to be able to see these lines. Okay, let's zoom in a little bit, and I'm going to create two rectangles stacked on top of each other. These will represent the tooth of the finger and the gap between the fingers. I'll make the one edge equal and collinear, then I'll make the segment between them equal and collinear. And now I'll add the dimension to it, which will be the width of the finger. Now you'll see me refer to the fingers as tenons, because I want to refer to the gap between them as mortises. I don't know if that's the right terminology, but that's kind of what I settle on here. So the only dimension I really have to define is the width of that finger or tenon. I'll make the top of it collinear to the top of the front. Make the left side collinear there to the outer edge, and the inside edge is collinear to that little construction line I drew on the front sketch earlier. Okay, so on the front piece, we're going to have a tooth on the outside of both top and bottom, and that means there's the second box, the lower box, is a gap. I'm going to consider this a mortise, and I always apply the tolerances to the mortise. You can do it however you want. This is just the way I think about it, is that this has the more sides that need some sort of tolerance on them, so I've just I'll use offset entities to create a box around that construction line of the second rectangle. Then I just set the gap between that offset entity as to the tolerance. And you're going to see me play with this a little further on in the videos, because this is a pretty cool little feature here. Now what I'm going to do, I want to be able to have any number of fingers. I want the box sides to be expandable into any dimension, or to be able to play with the width, the height, and the length. Which means I also want to play with the number of tenons. And so the way I do this is the technique I use. So I created that little sketch. Now I'm using linear sketch pattern to repeat one to the right and then one down. That's all I need. Don't need to go any further than that, because I'm gonna change that count. I'm gonna change that to a global variable and to side tenon count. So now got a couple more steps here. One of them, let's see here. I'm going to make that line there collinear with that line there, and now I've got the boxes, the repeating boxes stacked on each other, and I'll make that construction line collinear with the other edge of the box, and that's the tenons are done, or the mortises are done here. I'm going to unhide the extrusion, and now I'll do a cut extrude to get those mortises out of there. It's going to go through all, and now you can see I've got the cut extrude there. I've got the mortises of that finger joint cut. Like I said, mortises just seems to be a shorter way to refer to the gap between the fingers. I mean, if you want to think of it that way, that's why I called it that. All right, so when you've got those square bottoms, if you're cutting it on a CNC, you're going to need a dog bone down there to square off those corners. So the way I've done this is I've hid the skeleton sketch part front sketch. Now I don't need it anymore. I'm going to start referring to the geometry I drew for the side mortises. I'm going to pull that box, the two stacked boxes, and the offset entity, convert them all to construction lines, and now I'm going to turn that off so I don't accidentally have my lines connected to the side mortise sketch. All right. I've played around with a bunch of different ways of drawing these dog bones. The problem I'm having is sometimes they flip to the outside. The other, they flip across that horizontal construction line. I'm really not. This seems to work pretty well. I don't know that it's bulletproof, but it seems to work pretty well. All right, now I'm just going to mirror this dog bone across center line, so I don't have to go through that, making that little T again. All right, now I've got it. All right, so a linear sketch pattern won't work here, because if I use the linear sketch pattern, those dog bones would end on the tip of the fingers on the other side. I've got to mirror that those two dog bones across the right plane. You'll see, to get them in the right place. It doesn't seem. It took a minute to figure out what was going on there and how to work around this. It really took a minute to figure out the most efficient way to do this. And I should mention that I can't put this geometry in the skeleton sketch part because those repeating patterns, I want them to be variable. And if I put those patterns in the skeleton sketch part and I try to use something like a convert entities, it doesn't work real well, or at least I haven't been able to get it to work well. It works well as long as you keep increasing the tenon count on both sides, but as soon as you reduce it, like if you go from 3 to 2, reduce the count from 3 to 2, then you will get 2. You'll get your 2 tenons, but when you go back to 3, you'll get your 2 tenons. And so at least that's been my experience. So I don't know, maybe there's a different way to do it, but this is pretty dang bulletproof if we do it here. So that's why this these dimensions, this geometry is going on at the part level and not at the skeleton sketch part level. So you can see here we did yeah, there you go, the dog bones are in. Now I'm going to flip it around and let's draw the bottom slot for the bottom. And I'll say even before we get into this that I'm not going to put dog bones on this slot because it's pretty tiny. There's not much wood left on the end of that finger to be drilling holes or drilling dog bones and things like that. I think it just oversize it a little bit, and that's how I handle it. So another point to mention here is I put the offset entities on this. Remember, this is a mortise. I treat this as a mortise, so I'm putting the tolerance on here. I've found that one tolerance, or the tolerance that I've been using for everything else, like the fitting the fingers, is not quite enough for the bottom. I invariably am having to sand the edge of the bottom down. So I'm going to say let's double the tolerance around the bottom. And then we'll cut it. We're going to unhide the extrusion, and this time instead of doing a cut all the way through, obviously that's not going to work. I'll do a blind extruded cut and I'll set this global variable to the box bottom rabbet depth plus 2 tolerances. I'm having to type this in, but you can see the green check. I'm good. All right. And you can put, a visible dimension on the blind extruded cut. So there you go. So now the front back part is mostly finished. And here you can see there's not much wood for a dog bone. I think if I can sand that corner down a little bit of the bottom if I need to get that to fit. So, but I'm not going to worry about a dog bone there. Okay, that part's finished. We're there. Just rebuild it and save it. There we go. So our first part's done, and you can kind of see how this, using that skeleton sketch part, makes pretty quick work of it. But we've got some really cool things coming with that skeleton sketch part.